Okay, this is calculus time. I had sent out a review for the first exam. It's very important. I remind you the exam is on Wednesday from 1 to 3. It's treated just like the homework in the sense you will get the exam at 1 o'clock by email and post it on Blackboard. Do the exam, convert your exam pages into PDF file, and you upload it to Blackboard exactly the same way you upload your homework. Right? So the exam will be emailed at 1 p.m. on Wednesday. Do the problems. Obviously, you can do them in any order you want, but when you collect your pages at the end, I want the problem submitted in order as a PDF file. To the Blackboard assignment section. Just like you do with the homework. So you'll see a place that says exam 1, and that's where you submit your exam. All right, are there any questions about that? No? Any questions about homework or anything we've done so far on derivatives?
Professor,
Yes.
can we solve the review sheet, please?
Go over the review sheet?
I'm sorry?
You want me to go over the review sheet?
Yes, please.
Yeah, okay. That's exactly what I'll do.
Okay, thank you.
So on the review sheet, the first problem is calculating some limits. So the limit as x goes to 1 of x cubed plus 1 over x squared plus 1. This is just 1 cubed plus 1 over 1 squared plus 1, which is 1 plus 1 over 1 plus 1, or 2.
Professor, I have a question.
Yeah.
Can we do the limit of x cubed over x squared, and then cancel the x?
No.
We cannot do that.
No, it's not true. I mean, it might give you the right answer sometimes, yes. But this is not the same as x cubed over x squared.
Okay. So you don't advise, right?
I'm sorry, there was another question?
Yeah, go ahead.
Yeah, so for B, where the 2 is, isn't it 1 plus 1 is 2 over 2? So wouldn't it be 1?
Oh, thank you. I'm sorry. 2 over 2 is what I meant to say, is 1. Thank you very much. It is definitely true, even in calculus, no matter how advanced you get, that 1 plus 1 is 2.
Sometimes 1 plus 1 is 10.
No. You'll be in trouble if you push that too far.
Yeah, okay.
Limit as x goes to 0 of 8x to the 4th, sorry, x goes to infinity, 8x to the 4th minus 3x squared plus 11 over 5x to the 4th plus 1. So the theorem about the limit of a rational function as x goes to infinity says that if the numerator and the denominator have the same degree, the limit is just the ratio of the leading coefficients of the numerator and denominator. So it's 8/5.
Yeah, that's what I was saying here.
No, that's when x goes to infinity, not when x
Okay.
goes to 1.
All right, got it.
Yeah.
Thank you.
Yeah, now that's important.
Okay.
Okay,
We don't have to show any work for that one?
you get credit for having the right answer. If you have the wrong answer and I see that you did something intelligent in the work, you can get partial credit perhaps, but you don't lose any points if you have the right answer. You know, I mean, if you close your eyes and a voice from the sky tells you the answer and you write it down and it's correct, it's correct. Okay. C, we have a trigonometric limit as theta goes to 0 of sine of 3 theta over 2 theta. And it would be nice if we have a 3 theta here to have a 3 theta in the denominator. But 2 theta is the same as 3 theta times 3/2. So if I do this, and then I can take the 3/2 outside the limit. So 3/2 times the limit as theta goes to 0 of sine of 3 theta over 3 theta. And this limit is 1, so it's just 3/2 times 1 or 3/2. Okay. So as I go over the problems, please stop me if you have any questions so I can explain more.
Professor, why sine of theta over theta is now 1 and you multiply by 3?
So the basic limit that we proved in the class is that the limit of sine theta over theta as theta goes to 0 is 1. So that's an important theorem that we proved, and we have to be able to use it.
Exactly.
All
So
right?
what about if we just like we can say sine of theta over theta is 1, and then the 3/2 is what the limit is.
So this is true. And the limit of sine of 3 theta over 3 theta as theta goes to 0 is also 1. But the limit of the sine of 3 theta over 2 theta as theta goes to 0 is not 1.
It's not 1, right? But what about if so we cannot pull the 3/2 outside and leave sine of theta over theta? We cannot do that.
Well, in fact, that gives you the right answer. But the reason it gives you the right answer is because of the argument I gave here. But if you get the right answer to a problem, I don't care what method you used. If you get the right answer, it's the right answer. Okay. And then D is the limit as theta goes to 0 of t times the cotangent of t. So you have to know what the cotangent is. The cotangent is the cosine over the sine, which if you rearrange it is the same as the cosine times t over sine t. And so that's the limit as theta goes to 0. Sorry, as t goes to 0. Oh, sorry. There's a typo. I should have this. This should be that. Either they should all be thetas or they should all be t's. It should be the same variable. So the limit of cosine theta as theta goes to 0 times the limit of theta over sine theta as theta goes to 0. When theta goes to 0, the cosine goes to 1. Sine theta over theta goes to 1, so the reciprocal goes to 1 over 1, which is also 1. So the answer is 1.
Professor, I don't get this part,
Well, which part?
this one. Because sine
Theta,
over,
theta cotangent theta, okay?
yes,
The cotangent is the cosine over the sine. So this is the limit of theta cosine theta over sine theta. Is that okay?
yes, I get
Okay.
that.
So all I'm doing is this: theta cosine theta over sine theta is the same as cosine theta times theta over sine theta. Is that okay?
Yes,
All right. If you don't like theta over sine theta, this is cosine theta times 1 over sine theta over theta.
so,
And as theta goes to 0, this
okay.
goes to 1 and this goes to 1. So as theta goes to 0, you get 1 times 1 over 1, which is 1.
What is sine of 0?
You tell me, what's the sign of 0?
Is 0, right?
Correct.
Exactly. So when, like you said, cosine theta times theta over sine theta. So I mean, it will be like theta over 0 there, multiplied by cosine theta.
Well, you're saying it would be 0 over 0.
Yes, 0 over 0,
Okay.
which is
So that obviously is nonsense. And we proved this theorem. All right.
yes.
So you can't always just plug in. You can't just plug in theta equals 0. Because if you plug in theta equals 0, you get 0 over 0. But in fact, we prove that for sine theta over theta, as theta goes to 0, the limit is 1. We proved this.
Yes, we did.
That's what we're using.
Mhm.
This is going to 1 and this is going to 1. So the product is 1. All right. Are there any other questions? Okay. Problem 2, we have a function defined as follows. It's equal to 3 times the absolute value of x over x for x different from 0, and it's equal to 1 if x equals 0. So what is the value of f of 1? 3 times, so 1 is different from 0. It's 3 times the absolute value of 1 over 1, which is 3. What is f of minus 1? It's 3 times the absolute value of minus 1 over minus 1. The absolute value of minus 1 is plus 1. This is 3 over minus 1, or minus 3. And f of 0 is 1. If we want to graph f of x from minus 2 to 2, when x is positive, f of x is 3 absolute value of x over x is 3x over x is 3. When x is less than 0, the absolute value of f over x is 3 times the absolute value of x over x That's 3 times minus x over x. That's minus 3. And at 0, we're told the value of the function is 1. So this function is continuous at x equal 1. The function is just this constant function 3. But at x equals 0, f of x is not continuous at x equals 0 because the limit of f of x as x approaches 0 does not exist.
So, Professor, here you said the limit of x when x approach to 0, it doesn't exist, right?
Correct.
And
If you take the limit from the right,
yes,
as x goes to 0 from the right,
I
it's
cannot see
3.
your picture, please.
And the limit of f of x as x goes to 0 from the left is minus 3. So it has a limit from the right and it has a limit from the left, but they're different, which means the actual limit does not exist.
So why did you point on the 1?
Sorry?
Why did you like, I don't get the y on the graph, the 1, y equal 1. What is
Yeah,
that? Yeah.
that's the way the function is defined. The definition of the function is at x equals 0, it's equal to 1.
Y equals 1. And where did you place that?
What?
Where did you place that? The 1.
When x is 0, it's 1.
Okay, so we have to place that too.
Well, if it says graph the function, yes.
Okay.
It says explain your answer.
Yeah.
Okay, so we would explain it like x f of x is continuous at x is 1. Why would that be? Because
Because
there's a limit.
no, there are 3 conditions that have to be satisfied. So a function f of x is continuous at x equal a, some number a, if, first of all, the limit of f of x as x goes to a exists. Second, f is defined at a. And third, the limit of f of x as x approaches a is equal to the value of the function at a. So the value of the limit as x approaches 1 exists. The value of the function is 3 at 1. And the limit as x approaches 1 is 3. So these 3 conditions are satisfied. For D, the limit does not exist. So that condition fails and the function is not continuous. Problem 3 is similar. In problem 3, we have a function f of x defined to be 1 over x squared for x different from 0, and 1 when x equals 0. So f of 1 is 1. F of minus 1 is 1. And f of 0 is 1. Okay. And when we graph the function, it looks like this. That's the graph of the function. And this is continuous at x equal 1. That is right here. Plus, as you approach 1, the limit exists, the function is defined, and the value of the function at 1 is the limit. But it is not continuous at x equals 0 because the limit of f of x as x approaches 0 does not exist.
Professor, how did you get that graph?
I'm graphing 1 over x squared, right? You're supposed to know what that looks like. It just decays, just like that. As x goes to infinity, it's positive because it's a square. As x goes to infinity, it's going to 0. As x goes to 0, it's going to plus infinity.
Professor, I got a question.
Yes,
So the limit doesn't exist because they're both heading towards infinity. So it won't,
correct.
there's nothing to answer. It's just infinity though.
Well, you can say the limit is infinity, but but the limit is, there's no finite number, which is the limit. The limit does not exist.
Okay.
One way in which a limit doesn't exist is if the function is approaching infinity as you're approaching the point.
So here, when we say the limit is infinity, is correct?
It's correct, but that's not what you're asked. That's not what you're being asked. It's a correct statement, but it doesn't answer the question.
Okay.
Okay.
Can you do part B? You skipped it.
No, part B was to graph the function. Here's the graph.
Professor, I have a question.
Go ahead.
What about if f of x was like 1 over x squared, x different than 0, and x plus 1, x equals to 0, or I don't know, something like that. Instead of 1, we have x in the bottom.
Well, but it doesn't make any sense because that would only be when x equals 1. X equals 0, the way you described it.
Okay, so let's do it to see. I don't know how to graph that.
But it doesn't make any sense. What you said doesn't make any sense. You're saying
Yes.
f of x equals x plus 1 when x equals 0?
No, when x is equal to minus 1, for
When x equals minus 1?
yes.
Then f of minus 1 is minus 1 plus
No,
1
I'm
is
not.
0.
I'm not saying that. Like the whole first f of x. You said the function.
I don't know.
Instead of 1.
Are you trying to invent a different problem?
Yes.
Okay.
With the first function, yes.
Well, there's only one function.
Yes, the first one. I would like to put like another function like in the bottom. Instead of 1, we put like x plus 1 there.
You mean like
Or x minus 1.
f of x equals 1 over x squared for x different from 0?
Correct.
And what do you want me to put here?
Anything like x plus 1 or x minus 1.
X plus 1. Okay, when x equals 0. What does that mean? You're only doing this when x equals 0. So that's the same as writing 1. If this is only when x equals 0, when x is 0, x plus 1 is 1.
X plus 1 is
When
not
x is
minus
0.
1.
What?
It's not minus 1, is 1?
When x is 0?
Yes.
What's 0 plus 1?
Oh, okay. Oh, you switch it. I see.
No, I'm not switching anything. I'm just trying to write down what you told me. You want this to be a -1? Then it's 0 minus 1. It's -1. But it makes no sense to write this. It's not necessary.
Okay, so but I'm trying to know how to solve when like the function is now 1 in the bottom and it's x, something like that.
But if it's at a particular, no, I mean, you might have f of x equals x plus 1 for x greater than 2
Mhm.
and x minus 1 for x less than or equal to 2. Is
Okay,
that
right.
what you mean?
Yes, so it's what I
Okay,
mean.
so let me just put this in here. So suppose f of x is equal to x plus 1, let's say for x greater than or equal to 2, and x minus 1 for x less than 2, okay? So what does the graph look like? So here's 2. So for x greater than or equal to 2, that means on the right side of this line, f of x is x plus 1. So it's a line that looks like that. That's the line y equals x plus 1 for x greater than or equal to 2. And when x is less than 2, it's x minus 1. So that's the line that looks like that. So the graph of this function will be this line, and then it jumps over to here, and then that line. Okay. When x is bigger than 2, it's x plus 1. When x is less than 2, it's x minus 1. Okay. That's what the graph would look like. Okay. You divide it up into the two cases.
Professor,
Yes.
how do you know where to plot those points? Like for x minus 1, you put it at
It's x
coordinates.
minus 1 for x less than 2. So this is the line y equal x minus 1. That's the line that looks like this. Slope 1, y-intercept minus 1, but it stops at 2. That's what it
Oh,
is.
So we have to determine y values, correct, right?
If you're given the function, you do what the function tells you to do.
Okay.
Yeah. Let's see, there's one more problem like this on the review sheet. This is number 4. Here, f of x is just 1 over x squared plus 1 for all x. So f of 1 is 1 over 1 squared plus 1, which is a half. And f of minus 1 is 1 over minus 1 squared plus 1, which is a half. And f of 0 is 1 over 0 squared plus 1, which is 1. And if you graph this function, it's 0, it's 1 at 0. At 1 and minus 1, it's a half. And in fact, this function looks like that. It's this curve that looks like that. It's a very nice curve. And the function is continuous at x equal 1 and at x equals 0, because the function is defined everywhere, the limits everywhere exists, and it's continuous everywhere.
Exactly. So can we just say that the function is continuous everywhere?
Yes.
Or at all the value of x.
Correct. That's correct. It is correct to say that. Okay. Let's look at number 5. we have a series of functions to differentiate. So if f of x is the polynomial, x to the 10 minus 11x to the 5th minus 3x to the 4th minus 2x squared plus 17, f prime of x is 10x to the 9th minus 11 times 5x to the 4th minus 3 times 4x cubed minus 2 times 2x plus 0. So this is 10x to the 9th minus 55x to the 4th minus 12x cubed minus 4x. So this is just differentiating a polynomial term by term. Any questions about that?
Excuse me, Professor.
Yeah,
So what is next to the 10x over 9?
there is no 10x over 9.
Oh, sorry. Is that a 4?
Also, it's 10x over 9.
10x to the power 9.
Yeah, 10x to the power 9. So
Yeah.
that's what he's asking. It's 55x to the power 4.
Yeah, 11 times 5. The derivative of x to the 5th is 5x to the 4th times 11. Gives you 55.
Professor, you said the review is uploaded already to Blackboard?
This review,
The questions?
I mean, what I'm doing right now,
Yeah.
it's on Blackboard, and I also emailed it to everybody over the weekend.
I haven't received that email.
Oh, well, but if you go to course materials on Blackboard, you should see it. I believe that's where I posted it.
Course material?
Yeah.
Oh, I see. Thank you.
Okay. So 5b, we have the function f of x equal x to the 1,000th power times cosine x. So you use the product rule. It's the derivative of x to the 1,000, which is 1,000 x to the 999 times the cosine of x, plus x to the 1,000th times the derivative of the cosine, which is minus sine x. So it's that. All right, so that's just an application of the product rule.
Excuse me, Professor.
Yeah,
Can I see the top portion real quick? I just want to make sure.
Yeah.
Okay, thank you.
yeah, but I'm also recording this, and it'll be posted on YouTube, so you can always check it there as well. Okay. Part C is the function g of x equals x cubed minus 1 over x cubed plus 1 is the quotient. So we differentiated using the quotient rule. It's the denominator squared, and the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator. And there's some simplification because, so g prime of x, if we expand the numerator, we get 3x to the 5th plus 3x squared minus 3x to the 5th plus 3x squared. So this is 6x squared over x cubed plus 1 squared. Any questions about this yet?
No question, Professor.
So D is to differentiate the tangent. And it's easiest, if you don't remember the answer, to write this as sine t over cosine t. So then you use the quotient rule, denominator squared, the derivative of the numerator times the denominator, so you get cosine squared, minus the numerator times the derivative of the denominator, which is minus sine t. So minus times minus is plus, cosine squared t plus sine squared t over cosine squared t. Cosine squared plus sine squared is 1, and 1 over the cosine is the secant. So the rule you usually remember is the derivative of the tangent is the secant squared.
So what about if we leave the 1 over cosine square?
This is correct also. They're both correct.
Thank you.
Either one would be fine. E is the function secant t, which is 1 over the cosine. So we could differentiate this using either the quotient rule or the chain rule. So if you use the quotient rule, you get r prime of t. I have cosine squared t in the denominator. The derivative of the numerator, but the derivative of 1 is 0, minus 1 times the derivative of the denominator, which is minus sine t. Minus times minus is plus. So this is sine t over cosine squared t, which is sine t over cosine t times 1 over cosine t. If you write, I mean, this is okay, but if you write it like this, you also get tangent t secant t is the derivative.
Can we just write the answer automatically, or do we have to do all this?
If you know the answer, just write it down.
Okay, thank you.
Another way to do this is,
Sorry, Professor, I have a question.
yes, go ahead.
You said like we could just write the answer. How about if we don't have the right answer, but we show work, will we get partial credit?
It depends on the work, but if the work makes sense and then you've made a mistake along the way, you'll get partial credit.
Okay, thank you.
If you just write down the answer and it's right, you get full credit. If you just write down the answer and it's wrong, you get 0 credit because there's nothing to give you credit for.
You can give 1.
I could give 1,000, but you know. Let's see, another way to do this, where r of t is secant t, which is 1 over the cosine of t, which is the same as the cosine of t raised to the power minus 1. I could also do this using the chain rule. R prime of t would be minus cosine t to the minus 2 times the derivative of the cosine, which is minus the sine. The minuses cancel. I get sine t over cosine squared t again, which is Again, tangent t, secant t. So I just wanted to point out, you could also solve this problem using the chain rule. Let's see, f, we have the function r of t equal e to the t tangent t. So by the product rule, r prime of t is the derivative of e to the t times the tangent. Derivative of e to the t is e to the t, plus e to the t times the derivative of the tangent, which we just worked out as secant squared t. Or I could factor out an e to the t if I want. And I get something like this. You know, there are lots of ways you can rewrite it, but any way that's correct is fine. And once you get an answer that's correct, you might as well stop. If f of x is sine x over x, by the quotient rule, f prime of x, I have x squared in the denominator. Derivative of the numerator is cosine x times the denominator minus the numerator times the derivative of the denominator, which is 1. So that's the answer.
Professor, what is that? This is sine x over
X.
x. Okay.
In h, we have the function f of x is sine x plus 1 to the 7th power. So f prime of x by the chain rule is 7 sine x plus 1 to the 6th times the derivative of sine x plus 1, which is cosine x. Okay. Any questions about these so far? H of t is the log of t squared. The easiest thing to do is to write log of t squared as 2 log t. So h prime of t is 2 times the derivative of the log, which is 1 over t. So the answer is 2 over t. Right? You're allowed to use the properties of logarithms and exponentials.
Professor, I didn't get this part.
Well, you know that the log of t squared is 2 log t,
Yes, I know that.
and you know the derivative of log t is 1 over t.
Yes.
So the derivative of 2 log t is 2 over t.
Thank you.
And then finally, if we have the function e to the minus x squared, by the chain rule, the derivative is derivative of minus x squared minus 2x times e to the minus x squared. Okay. All right. Number 6. So for number 6, we have the curve y equals x cubed minus 9x, and we want to find the tangent line. At x equal to 2. So that'll be y is equal to the derivative of the function. Let's see. Suppose I call this function f of x. It's going to be equal to f prime at 2 times x minus 2 plus the value of the function at 2. So if f of x is x cubed minus 9x, the derivative is 3x squared minus 9. When you evaluate f at 2, you get 2 cubed minus 9 times 2. That's 8 minus 18 is minus 10. And then when you evaluate the derivative at 2, 2 squared is 4, times 3 is 12, minus 9 is 3. So y is equal to 3, x minus 2, minus 10. So that's 3x minus 6 minus 10, or 3x minus 16. So the tangent line is y equal 3x minus 16. Now, let's just try and sketch by hand what the graph of the function looks like. This is y equals x cubed minus 9x. That's like x times x squared minus 9. That's x times x minus 3 times x plus 3. So this function is 0 at 0, at 3, and at negative 3. And when x is equal to 1, it's 1 cubed minus 9, it's minus 8. So at 1, it's minus 8. At 9, at 2, it's minus 10. And let's see, let me just double check this. So if y is x cubed minus 9x, then when x is 1, it's minus 8. And when x is 2, it's minus 10. And when x is 3, it's 0. And the derivative is 3x squared minus 9. So when x is equal to 2, this is plus 3. Okay, that's all good. I mean, the graph of this function, it's 0 here, 0 here, sort of goes up, comes down. Turns around and goes up again. And here is the point when x is equal to 2, y is minus 10. And the tangent line is 3x minus 16. Looks like that. Tangent line.
So, Professor, I have a question.
Yeah,
When you said to graph the function, you don't need the absolute value. We can graph it by hand.
yeah, that's all. Yeah, just to sketch the graph.
Okay. You don't need the absolute values, right?
You mean the actual values?
Yes.
Well, it's good. I mean, I found the actual values at some points
Yes.
enough to understand what was going on, but yeah.
Okay.
Okay. Problem 7. We have a parabola. F of x equals x squared minus 4x plus 6. And, oops, sorry. Yeah. We want to find that, so f prime of x is 2x minus 4. So I want to find the tangent lines at 1 and at 3. So at x equal 1, f of 1 is 3, and f prime of 1 is minus 2. So the tangent line is y equals minus 2, x minus 1 plus 3 is minus 2x plus 5. And at x equal to,
Hello, Professor. Excuse me.
yeah,
Where did you get the x minus 1?
well, so for a tangent line, you have to know the point slope formula.
Yeah, I know that.
Okay, so the point slope formula says
M equal to,
if you want to find the line, the tangent line to the curve at x equal a, it's y equals f prime of a times x minus a plus f of a. And in this case, a is equal to 1. You're finding the tangent line to the curve at x equal 1. So it's y equals f prime of 1 times x minus 1 plus the value of the function at 1. That's this. And at x equals 3, the tangent line is the derivative of the function of 3 times x minus 3 plus f of 3. If this is my function, f of 3 is 3 squared is 9, minus 12 is minus 3 plus 6 is 3. And f prime of 3 is 6 minus 4 is 2. So this tangent line is 2 times x minus 3 plus f of 3, or y equals 2x minus 6 plus 3, 2x minus 3. That's the second tangent line. So, and now it's a nice exercise to try and sketch what's going on. So this is my function, x squared minus 4x plus 6. If I want, I can write this as x minus 4x plus 4 plus 2, because then this is x minus 2 squared plus 2. So this is as if you take the parabola y equal x squared, you shift it by 2 and lift it by 2. So f of 2 is equal to 2. We already saw f of 1 is equal to 3. F of 3 is equal to 3. When x is 0, you get 6. When x is 3, sorry, 1, 2, 3, 4. When x is 4, you would get 16 minus, you would also get 6. So you just get this very nice parabola. And the tangent line at x equal 1 is minus 2x plus 5. And the tangent line at 3 is 2x minus 3. And those two lines cross at some point. So we want to find where they cross. That is, we want to solve y equal 2x minus 3 and y equals minus 2x plus 5. So when they're equal, 2x minus 3 is minus 2x plus 5. 4x equals 8, or x equals 2. So they meet when x is equal to 2, and when x is equal to 2, y is equal to 1. So the point of intersection of the two lines is 2, 1. Okay. All right. Is there a question? Any questions about this?
Did you get the y equal 1? Did you switch from
So these are my tangent lines.
yes?
They cross when x is equal to 2. And if you plug x equal to 2 in either one of these lines, you get
Okay.
y is equal to 1.
All right. Let me see.
Okay. Problem 8 is to use the definition of the derivative to compute some derivatives. So if you have f of x equals x squared, you know f prime of x equals 2x. But if you just write this down, you get 0 credit because that's not what the problem is. The problem is to use the definition of the derivative to prove this. So f prime of x is the limit as h goes to 0, f of x plus h minus f of x over h. That's the definition. So for f of x equals x squared, f of x plus h minus f of x is x plus h squared minus x squared. That's x squared plus 2xh plus h squared minus x squared. These cancel. You get 2xh plus h squared. So f of x plus h minus f of x over h is this. I can factor an h out of that. 2x plus h times h over h is 2x plus h. So in this limit, I'm taking the limit as h goes to 0 of 2x plus h. As h goes to 0, I'm just left with 2x. And that's how we use the definition of the derivative. Right? Okay. Other question?
So this is number 5.
It's number 8. 8a. And 8b is to use the definition to compute the derivative of 1 over x. So f of x plus h minus f of x is 1 over x plus h minus 1 over x. If you put that over a common denominator of x over x plus h, you get x minus x plus h, which is minus h over x times x plus h if you do the algebra. So f of x plus h minus f of x over h, divide this by h, you get minus 1 over x times x plus h. And then we take the limit as h goes to 0. As h goes to 0, you get minus 1 over x times x. So this is a proof that the derivative of f of x equal 1 over x is minus 1 over x squared, which of course you knew by the power rule, right? You know that the derivative of x to the minus 1 is minus 1 x to the minus 2 or minus 1 over x squared. But this is the proof. This is what you needed to do for this problem. And then the last part of problem 8 is to find the derivative of the sine. So f of x plus h minus f of x is the sine of x plus h minus the sine of x. So you can expand this using the addition formula for the sine. This is sine x cosine h plus cosine x sine h minus sine x. That's equal to, let's see, I have this term, cosine x times sine h minus sine x times 1 minus cosine h when I rearrange this. So using the addition formula for the sine, I get this. And if I divide by h, I have this. And now remember the limit sine h over h as h goes to 0 is 1. And the limit of 1 minus cosine h over h as h goes to 0 is 0. So the limit of f of x plus h minus f of x over h, when this goes to 0, when h goes to 0, you get cosine x, and this limit is 1, minus sine x, and this limit is 0. So that disappears, and we just get cosine x. So that's the proof from the definition that the derivative of sine of x is equal to cosine x. Any questions about that?
Yes, question, Professor.
Yeah, go ahead.
Why did you say the limit of 1 minus cosine h over h when h is approaching to 0 is 0?
Because I proved that. We had two theorems about trigonometric limits. We proved that in the very beginning of the course, we proved the limit of sine h over h as h goes to 0 is 1.
That's right.
And we proved the limit of 1 minus cosine h over h as h goes to 0 is 0.
That's what I don't get.
Well, you mean you don't remember that we did this, or
No,
do you not understand why this one is true?
Yeah, I understand that.
Well, how do you prove this?
How do I prove it? You said this, okay, that will be a little difficult for me to prove it, but I know that the sine of h over h, the limit of sine of h over h is 1. I know that.
So if you know that, let me see if I can prove the second one for you. All right.
Yes.
So we're interested in 1 minus cosine h over h, right? And let me write this as 1 minus cosine h over h times 1. Is that okay?
Yes.
All right. But I happen to want to write 1 in the form 1 plus cosine h over 1 plus cosine h, okay? Because I'm still just multiplying by 1.
Okay.
All right. So in the numerator, I have 1 minus cosine squared h over h times 1 plus cosine h. Okay?
Yeah.
And 1 minus cosine squared is sine squared. Okay?
Yes.
And sine squared is sine times sine. So I can write this as sine h over h times sine h over 1 plus cosine h. Okay?
Right.
Now, what happens as h goes to 0? Sine h over h goes to 1.
One.
Right?
Yes.
Sine h goes to 0, and 1 plus cosine h goes to 1 plus 1, or 2. Right? This is just 0 over 2. This goes to 1 times 0, or 0. And there's a proof for you.
Thank you.
Yeah. But again, so it's nice to see the proof. It's an interesting exercise in using some trigonometric identities.
Yes.
But in this course, it's not, you don't have to know the proof. You just have to be able to remember. You have to remember the fact and be able to use it when you need to. But that is the proof, or that is a proof. There are lots of proofs.
Professor.
Yeah.
So this review will be on the videos on the YouTube, right?
Yeah.
All right. Cool. Thank you.
Sure. Okay. And the last problem was a little bit of like an application of elementary calculus, which has to do with the motion of a particle. If you start at a height s0 and you shoot a cannonball straight up into the air with some initial velocity v0, then the trajectory is determined by the following formula. The height at time t is minus 4.9 t squared plus the initial velocity times t times the initial height. So, you know, this is nothing you have to remember. This is just what you're told. Right? And in the problem at hand, we're told the ball is shot from the ground. So the initial height, S0, is 0. And we're told that the initial velocity V0 is 196. So we're measuring things in meters and seconds. So the initial velocity is 196 meters per second. So the trajectory of the ball is determined by the equation minus 4.9 t squared plus 196 t plus 0. And if you look at the height as a function of time, when t equals 0, you're at 0. And this curve is a parabola. And you want to know at what time does the cannonball hit the ground again? So, sorry. We want to know the maximum height reached by the cannonball. So for a parabola, it's going to be like at the time is the average by the symmetry around this point. If we know when it hits the ground, this time will be half of that. So let me actually do part B first. When does the cannonball hit the ground? Cannonball hits the ground at time t when s of t equals 0. This is s of t. S of t is minus 4.9 t squared plus 196 t. If I factor a t out of that, it's minus 4.9 t plus 196 times t. So it hits the ground when, so ball is at ground level at height s equals 0 when you start, when t is equal to 0, and when minus 4.9t plus 196 equals 0. That means t is equal to 196 over 4.9. What is that? You have to divide 1960 divided by 49
It's 40.
is 40. Perfect. So at time t equal 40, it hits the ground. That's kind of strange. Yeah, well, 40 seconds to hit the ground. So the maximum height occurs at this value when t is equal to 20. Oh, sorry. Let me also do the third part. So this is part C. If s of t is given by this formula, the velocity at any time is the derivative of the position. So it's minus 4.9 times 2t plus 196. So that's, let's see, 196 minus 9.8t. So for the velocity at time t equal 40 is 196 minus 9.8 times 40. Let's see, 9.8 times 40 is 98 times 4.
Sorry, we can't see what you're doing.
So here's s of t. So that's the position. The velocity is the derivative. So it's minus 4.9 times 2t plus 196, or 196 minus 9.8 times t. If it hits the ground after 40 seconds, then the velocity at time 40 is 196 minus 9.8 times 40, which is what? 98 times 4 is 392. So that's minus 196. So it's traveling at a minus 196 meters per second when it hits the ground. And the maximum height is just the height at time 20. So it's minus 4.9 times 20 squared plus 196 times 20. So if you do the arithmetic, let's see, 196 times 20 is 3,920 minus 4.9 times 20 squared. 20 squared is 400. So 400 times 4.9
It's 1960.
1960. So the maximum height is, so 3920 minus 1960 is another 1960. So it reaches a maximum height of 1,960 meters.
So you mean to solve B and C first before we can solve C?
Well, in this instance, yes, the way I wrote the problem, I should have put it in a different order. But yeah, because if you know a little bit more calculus, you could have done this right away, because but we haven't learned this yet. If s of t is, what is s of t? Minus 4.9 t squared plus 196t, the derivative is minus 9.8 t plus 196. And we want to know, when does this equal 0? So it equals 0 that when 9.8 t is 196, or t is 196 over 9.8, or 1960 over 998. And that's equal to 20. So the maximum height will occur where, so if you think of it like this, the ball is shot in, this is with time. It goes up in the air and then it's coming down. When it's going up in the air, the velocity is positive because it's moving up. When it's coming down, the velocity is negative. And at the very point at which it's at its maximum height, the velocity is 0. So if you find the time at which the velocity is 0, that at that time, the cannonball will reach its maximum height. So you just compute S of 20 equals the maximum height.
Professor,
Yeah,
how do you get the 20? Because
sorry?
you divide 1960 by 9.8, right?
90, no, it's 196 divided by 9.8, or
Oh, okay.
1960 divided by 98.
All right. Yeah.
All right, well, that's the review sheet.
Question, can
Yeah.
you please review, do part B again? Or
Part
show
B.
us how you explain it?
The time when the cannonball hits the ground?
Yeah,
Okay. So again, all you have to do really is look at this picture. So the height at time t is given by this formula, right?
mhm,
What's the height when it hits the ground?
0.
Height at ground is 0. So the particle is at ground level when the height is 0. So you just solve this equation, S of t equals 0. That's minus 4.9 t squared plus 196 t equals 0. Solve that. Well, you factor out a t. So this is minus 4.9 t plus 196. So either t equals 0 or this is equal to 0. So minus 4.9 t plus 196 equals 0. So t is 196 over 4.9, which is 40.
Okay, thank you.
Yep. So if there's any interest, I can arrange like a help session online tomorrow afternoon. So if you have any last minute questions, let's say around 4 o'clock tomorrow on Zoom, I'll send out an email and I'll be available to answer any last minute questions you might have about the exam.
Could you also post on Blackboard, Professor? Like just in case we don't get the emails?
Oh, I do. Yeah, I always put it as an announcement on Blackboard and by email. Yes. So tomorrow, Tuesday at 4 o'clock. And the same Zoom login.
So you mean we have class tomorrow for?
It's not class, it's like an office hour.
Thank you.
So if you have a question, come at 4. Usually when I set up these times, no one comes. So, you know, after 15 or 20 minutes, I go away. But if you have questions and you come at 4, I'll stay as long as is necessary.
Got it. Thank you, Professor.
Yep.
Have a good day.
Thank you. You too.
Thank you.